Hello. Now, in previous lecture we have seen bisection method and its examples. Now one important example is remained, or which is some different type. Here example is that using bisection method find the negative root of the x cube minus 4x plus 9 is equal to 0. Here f of x is equal to x cube minus 4x plus 9 is equal to 0 is given equation. Finding the negative root of given equation is nothing but finding the positive root of f of minus x. Here this concept is used. Therefore our given polynomial is x cube minus 4x plus 9 is equal to 0, and if we replace x is equal to minus x here, we get minus x cube plus 4x plus 9 is equal to 0. The negative root of f of x equal to 0 is the positive root of f of minus x is equal to 0. Therefore let f of minus x is equal to phi of x is equal to minus x cube plus 4x plus 9 is equal to 0. Now remaining process is same. We have to find first interval in which the root is belongs. For that we have to check the some basic values 0 1 2. Here if we replace x is equal to 0 in phi of x, we get 9 which is greater than 0, and if we replace x is equal to 1, we get 12 greater than 0 also, not opposite sign. Therefore again there is a choice. If we replace phi of x is equal to 2, we get phi of 2 is equal to 9 which is also greater than 0. Again we have choose x is equal to 3 here. If we replace x equal to 3, we get phi of 3 is equal to minus 6 which is less than 0. Here phi of 2 is positive and phi of 3 is negative. They are of opposite signs. Therefore root of phi of x is lies between 2 and 3. Therefore our first approximation is the arithmetic mean of these two values 2 and 3. Therefore x1 is equal to 2 plus 3 by 2 is equal to 2.5. This is our first approximation. Now we have to check by the same working rule what is the sign of phi of x1 means phi of 2.5. If we replace x is equal to 2.5 in phi of x, we get 3.375 which is a positive, and here phi of 3 is negative and phi of 2.5 is negative. Therefore they are of opposite signs. Therefore root lies between 2.5 and 3. Therefore again by that same working rule, second approximation is arithmetic mean of these two. 2.5 plus 3 divided by 2 is nothing but 2.75. Again process is same. Find the phi of x2, it is negative, and above phi of 2.5 is positive, and here phi of 2.75 is negative. They are of opposite signs. Therefore root lies between 2.5 and 2.75, and therefore our next approximation is 2.75 plus 2.5 by 2 is equal to 2.625. And again process is same. We have to find the negative root of this. Therefore by using that same working rule, we are reach at the 10th approximation here, that x10 is equal to 2.7072, and next is here x11 is 2.707, x11 is 2.707, and here x10 is 2.7072. Therefore x10 and x11 contains 707 is common. Therefore this 2.707 is the root of given polynomial, which is correct up to 3 decimal places. After the point there is a 3 decimal places 707. Up to this, that 3 decimal places, our answer is this. Therefore hence required root of phi of x is 2.707, and phi of x is nothing but f of minus x. This is the positive root of phi of x, but phi of x nothing but f of minus x, and we have to find f of x, root of f of x. Therefore put the negative sign there. Hence our required root is minus times 2.707. This is the example. Okay, now new method. We are going to study new method which is known as false position method or regular Falsi method. 75% process of the previous method is here same. Step is here, select two trial values A and B similarly like previous method and find f of A and f of B or of opposite signs. Second step is if f of A and f of B are of opposite signs, then first approximation is equal to x1 is equal to A into f of B minus B into f of A divided by f of B minus f of A. Then again find f of x1. There will be two cases. If f of x1 is greater than 0, root lies between x1 and B, because f of A is here assumed that positive, and if f of x1 is also positive and f of B is negative, therefore f of x1 and f of B are of opposite signs, therefore root lies between x1 and B. Therefore our next or second approximation should be x2 is equal to x1 into f of B minus B into f of x1 divided by f of B minus f of x1. And if f of x1 is negative, then root lies between A and x1, because f of A is positive, here f of x1 is positive, and f of x1 is negative and f of A is positive, therefore they are of opposite signs, therefore root lies between A and x1. And by the same theory, this is our definition here for the next approximation. X is equal to A into f of x1 minus x1 into f of B divided by f of x1 minus f of A. Formula for regular Falsi is this: x1 is equal to A into f of B minus B into f of A divided by B f of B minus f of. This is important formula, we have to keep in mind this formula. Okay, now repeat the third step till we get approximate root of f of x is equal to 0. We have to repeat this process x1 x2 x3 up to our desired solution is achieved. Okay, now we are going to look one example there. Find the positive root of x into log x to the base 10 minus 1.2 by false position method or regular Falsi method. There are two names for this method: false position method, or also it is called as regular Falsi method. Here f of x is equal to x into log x to the base 10 minus 1.2 is equal to 0. And if we replace x is equal to 1 here, we get 1 into log 1 to the base 10 minus 1.2. Log 1 is 0, therefore only remains with minus times 1.2. And f of 2 is after the calculation we get minus times 0.5979, which is also negative, therefore they are not opposite signs. Therefore again we have to choose 3. Here f of 3 is equal to 0.23136, which is greater than 0. F of 3 is greater than 0, f of 2 is negative, f of 3 is positive, they are of opposite signs, therefore root lies between 2 and 3 by that intermediate value. Theorem: this procedure is same for both the methods, previous one and that one. Now first approximation is equal to x1 is equal to A into f of B minus B into f of A divided by f of B minus f of A. Here A is equal to 2 and B is equal to 3. After replacing these values and calculating these values, we get x1 is equal to 2.72100. And if we are finding f of x1, means x1 is replace x by x1 in our given polynomial x log x minus 1.2, then we get f of x1 is negative. Here f of 3 is positive, f of 2.72100 is negative, therefore they are of opposite signs, therefore root lies between these two values 2.72100 and 3. Therefore our next approximation should be x2 is equal to this 2.72 A into f of B minus B into f of A divided by f of B minus f of A. Here role of A and B is played by 2. Role of A is played by 2.72100 and role of B is played by 3 here. And after calculation of x2 we get 2.74019, and if we replace x by x2 we get f of x2 is equal to minus 3 times 3.9776 into 10 raised to minus 4, and which is a negative also. And we know that f of 3 is positive, this is negative, therefore root lies between 2.74019 and 3. Same process, third approximation x3 is equal to 2.74019 f of 3 minus 3 into f of 2.74019 and divided by f of 3 minus f of 2.74019. Process is the same, and after calculating we get Next x3 is equal to 2.74063. Here we observe that x2 is 2.740 and here 3x3 is say 2.740. Up to 3 decimal places. Root is correct up to 3 decimal places. Okay, this is our first example. There is a process same in first, more than half process is same in both the methods. Okay, तर मधूनच मराठीमधून बोलतोय आता तुम्हाला. पहिल्या मेथडमध्ये जी आपण पाहिली बायसेक्शन मेथड आणि आताची जी मेथड आहे रेग्युलर फॉल्सी किंवा फॉल्स पोझिशन मेथड आहे, यांची जवळपास निम्यापेक्षा जास्त प्रोसेस सेम आहे. फक्त एकच फॉर्म्युला वेगळा आहे, तो म्हणजे x1 इज इक्वल टू a इंटू एफ ऑफ बी मायनस बी इंटू एफ ऑफ बी डिवाइड बाय एफ ऑफ बी मायनस एफ ऑफ ए. हीच फॉर्म्युला फक्त लक्षात ठेवायचा रेग्युलर फॉल्सी मेथडसाठी. ओके, बाकीची प्रोसेस सेम आहे, फक्त इटरेशन फाइंड करत जायचं आहे. पॉझिटिव्ह रूट फाइंड करायचं असेल, फक्त ट्रायल व्हॅल्यू चेक करताना महत्त्वाची गोष्ट कोणती आहे, 1 2 3 0 अशा व्हॅल्यू निवडायच्यात आणि अपोजिट साईन कुठलं येत आहे ते पाहायचं आहे. इथं आपण बघितलं 1ला सुद्धा निगेटिव्ह आलं, 2ला सुद्धा निगेटिव्ह आलं, म्हणून त्याच्यामध्ये रूट कधीच येणार नाही. अपोजिट साईन पाहिजे, निगेटिव्ह पॉझिटिव्ह किंवा पॉझिटिव्ह निगेटिव्ह पाहिजे. म्हणून एफ ऑफ 3ची व्हॅल्यू किती आली, इथं पॉझिटिव्ह आली आणि एफ ऑफ 2ची काय आली, निगेटिव्ह आली. इथं त्याच्यामुळं रूट कुठं आलं, आपल्या पॉलिनॉमियलचं अपोजिट साईनमध्ये आलं, 2 आणि 3मध्ये आलं. ओके, प्रोसेस इथं सेम आहे, करत राहायचं आहे. कधी कधी इटरेशन फाइंड करायला देतात की एवढ्या इटरेशनपर्यंत फाइंड करा किंवा स्टॉप करा, एवढेच अप्रॉक्सिमेशन फाइंड करा, तिथं स्टॉप करायचं आहे. कधी कधी प्रोसेस दिलेली नसते, त्यावेळेस काय करायचं, हे थांबायचं आहे कुठं, ही सगळ्यात महत्त्वाचा प्रश्न असतो. लागोपाठच्या 2 इटरेशनचे जे आपले आन्सर आहेत, जसं की उदाहरणार्थ हे एक्झाम्पल आपण बघितलं इथं की 2.740 हे x2 आणि x3मध्ये कॉमन होतं. जर 3 डेसिमल प्लेसेसपर्यंत त्यांनी सांगितलं असेल की बाबा करेक्ट करा किंवा 4 डेसिमल प्लेसेसपर्यंत करेक्ट करा, तर 4th विचारलं असतं तर आपण अजून पुढचं इटरेशन बघितलं असतं आणि 4th ॲप्रॉक्सिमेशनसुद्धा फाइंड केलं असतं आणि बघितलं असतं. ओके, तर अशा प्रकारे प्रोसेस आहे, काय अवघड नाही, टेन्शन घेऊ नका. फक्त प्रोसेस एकदा समजली की एक्झाम्पल सोडवा. भरपूर एक्झाम्पल महत्त्वाचे तर सोडवून दिलेले आहे त्या नोट्समध्ये, त्याचा सराव करा. टेन्शन घेऊ नका, कोरोनापासून स्वतःचं संरक्षण करा, बाहेर निघू नका. ओके, तर पुढचं एक्झाम्पल आपण अजून एक एक्झाम्पल पाहूया त्यातले. फाइंड द पॉझिटिव्ह रूट ऑफ x³ - 4x + 1 इज इक्वल टू 0 बाय रेग्युलर फॉल्सी मेथड. हिअर गिवन polynomial is x³ - 4x + 1. If we replace x is equal to 1, how to choose 1 and 2 here is how to choose our interval is important here. We have to just check some basics values 0 1 2 3. Out of only these value we have to use for the fixing the interval in which the root belongs. Okay, for that here if we replace x is equal to 1, we get minus. Here f of 1 is negative, f of 2 is positive, hence we get root lies between 1 and 2, interval 1 and 2. Therefore role of a and b is played by 1 and 2 respectively. Therefore our first approximation is equal to x1 is equal to a into f of b minus b into f of b divided by f of b minus f of a. Here a is equal to 1 and b is equal to 2. Okay, after substituting the values of x, a and b in given formula, we get value x1 is equal to 1.666 and f of x1. After finding the x1, our next target is finding the f of x1. We have to check when f of x1 is positive or negative. Here f of x1 is negative, therefore here observe that f of 2 is above we have seen that f of 2 is positive. Here f of 1.66 is negative, therefore our root lies between 1.667 and 2. Therefore our next approximation is x2 is equal to 1.667 into f of 2 minus f of 1.666 into 2 divided by f of 2 minus f of 1.667. After calculation we get x2 is equal to 1.4011. Similarly again we have to check f of x2, what is the sign of f of x2. F of x2 is here negative, f of x1 is here also negative, but f of 2 is positive. Therefore f of 2 and f of 1.4011 is are of opposite sign. Therefore our root lies between 1.4011 and 2. Therefore our next third approximation should be the x3 is equal to, here role of a and b is played by 1.4011 and 2 respectively. Therefore x3 is equal to 1.4011 and f of 2 minus f of 1.4011 into 2 divided by f of 2 minus f of 1.4011. After calculating, we get x3 is equal to 1.7900. Next target is same, finding the sign. If we replace x is equal to x3 in given polynomial, we get minus times 0.4246. Here this is also negative, f of 2 is positive, again root is belongs to 1.7900 and 2. Our fourth approximation is now here role of a and b is played by 1.7900 and 2. Therefore x4 is equal to this. Again process is same, finding f of x4. Again f of x4 is negative. The root lies between 1.8525 and 2, because the 2 and f of 2 and f of 1.8525 are of opposite signs. x5 is this. Again x5 is equal to 1.8598. f of x5 is again negative. Still process is continuing, but if they have given that correct up to 2 decimal places, then this should be the answer, our 1.8598, because x4 and x5 x4 also contains 1.85 and here x5 also contains 1.85. Therefore our root up to our given root of given polynomial is 1.85 up to 2 decimal, correct up to 2 decimal places. Okay. Similarly, these are the two examples for the homework. They are also given, a solution also given here. Process is same, just keep in mind working rule, how to work, and one formula is there, a into f of b minus b into f of a divided by f of b minus f of a. We have to just keep in mind this formula. All our process is the same like previous method. Okay, there is nothing difference, large difference in both methods. Now solve another examples. Okay, we have large source of examples are here, all are solved. If there is any doubt, they can ask, okay, anytime. Now next lecture we will see that Newton-Raphson method. Okay, now today I am stop here. Okay.